Hello! It seems as if you stumbled onto this video as you have been learning kinematics lately and you're struggling a lot because either you have a very bad physics teacher or just the concept doesn't make sense when you solve problems. So I'm here to help you. So let's have this example problem read. A car traveling 85 kilometers per hour strikes a tree. The front end compresses and the drive hole travels 0.8 meters before stopping. What was the average acceleration in G's that the car experienced? Okay, so one thing that's going to help us here is drawing a diagram. Draw a nice diagram. It doesn't have to be good, but it should just be there. Let's have this tree. Let's have the tree. Let's have our car crashed into the tree. So let's now write what we know. Let's change the color of the marker. Green. So the driver, let's draw him in here, he's in here. So the car initially, it traveled at a speed of 85 kilometers per hour. That is its initial velocity, otherwise known as V0. It's too dark to see, too light to see. Let me just go back to blue. So its initial velocity, V0, is 85 kilometers per hour. And then the final velocity, it hit the tree. So it's not moving. It's going to be final velocity of 0 meters per second. And we know that the initial position, we don't need to worry about how far the car has traveled beforehand. We can just say the initial position that the car is at is 0. And then its final position, as stated in the problem right here, it traveled 0.8 meters. So, what do we want to find out is the acceleration. Okay, so the first thing we need to do is get all our units organized. You can see we got meters per second, meters, kilometers per hour. No, that won't do. We need to make this kilometers per hour into meters per second. So let's do some dimensional analysis. Let's get another color. 85 kilometers per hour. We have to make this in meters per second. So let's cancel out the kilometers. For every kilometer, there's 1,000 meters. So then the kilometers cancel. Then we want to cancel out hours. So for every hour, there are 3,600 seconds. So then we cancel that out. So now let's put this into our TI. Let's get this into my calculator, see what we get. 85 times 1,000 over 3,600 equals to 23.61. So our initial velocity is 23.61 meters per second. So let's put that there by 23.61 meters per second. Now that we got that situated, we now actually have to solve the problem. So we're trying to find acceleration, and we have initial velocity, initial position, velocity, and position. So what kinematic equation can we use? So look at your formula sheet. You probably have one on hand, or you can look in your physics textbook. Just think which formula would have all these components. Initial velocity, initial position, acceleration, final velocity, and final position. Then when you found it, what you do next, write it. So the one that we're going to use, V final squared equals V initial squared plus 2 times acceleration times final position minus initial position. Okay, so we got this, right? Now what do we do with it? So we can do this one of two ways. So the first way is by solving for what we want to find. So let's do it here. So we need to solve for acceleration. So we can do that by doing, okay, v squared minus v initial squared equals 2 acceleration over all that. Then we divide both sides by 2 times the x minus x0. It's going to be this 2x minus x0 equals 2 acceleration. Okay, so now let's just plug it in. Plug in our values. So v final squared is 0, so that's just 0, minus v initial squared, which is 23.61 squared. Then we divide this by 2 times our initial position, which is 0.8 minus our final position, which is 0.8 minus initial position, which is 0, so it's 0.8, 0. And then what we get as our answer is negative 348.40 meters per second squared. Negative 348.40 meters per second squared. Now before we do anything, let's actually try it the other way that I've specified, so it said that it could be done. So let's do the other way. The other way is for the people who are a little scared of algebra. That's okay. It's just you substitute immediately after. So we can substitute velocity, but initial final velocity to 1. Our final velocity is 0 squared equals to 23.61 squared plus 2 acceleration. X minus x0 is 0.8. So let's solve for the acceleration now. We can now solve for all these values. 23.61 whole squared is how much? We get 557.43 plus 1.6 times the acceleration. Now this is a much easier algebraic equation to solve. So we can just do negative 557.43 equals to 1.6 times the acceleration. And then what we do next is we now solve. It's much easier to solve. 557.43 divided by 1.6. And that gives us the exact same answer. It might change by a little bit because of the rounding on your calculator if you set it to a specific setting, but that's okay. We get the same answer. 348.40 meters per second squared. Now the final step. We have to convert this into G's, as that's what it wanted us to put it in. Now we can just erase the diagram. And now we can solve this. It's a dimensional analysis once again. So let's use a different color. Let's use purple. So then we just take negative 348.40 and multiply it by, for every negative meters per second, and for every negative and for every positive 9.8 meters per second, we get 1 G. So then that will give us our G's by canceling out the acceleration. Then what that is we get negative 348.40 divided by 9.8 equals to negative 35.55. Negative 35.55 G's. Well, we're almost done. We have one more step. Sig figs. Everyone hates them, but you still have to do them. So this one has 2 sig figs. This one also has 2 sig figs. So I guess we're just using 2 sig figs then. So then this in 2 sig fig form, we round it up. Negative 36 G's. Negative 36 G's of force is going to be used. Is going to be the average acceleration as you crash into that tree. And negative 36 G's is probably going to kill you in an instant. You don't need physics to tell you that crashing into a tree is probably not a good idea. You're probably going to die. So, what did we learn? What are the steps you use to solve a kinematic equation problem? So, Step 1, diagram. You make a diagram of what you know. And step 2, find what you know and don't know. Find what you know and don't. Then step 3 is pick an equation. Like look at your sheet and see which equation would work out best. Then step 4, solve. So those are the 4 basic steps. If it doesn't work out, you can just go back to the start and then pick a different equation. And if you have more complex problems, you try and work backwards and solve for the other variables. So, one other thing we also learned is that you're not supposed to crash into a tree. Otherwise, you'll die. You don't need physics to tell you that. If you crash into a tree, driving 85 miles per hour, you are going to die. I hope you enjoyed this video, and goodbye.